Hello. Ladies and gentlemen, please take your seats. We're going to start soon. Ladies and gentlemen, بچه های عزیز دوستان بفرمایید جاهاتون رو بگیرید. صندلی ها امشب محدود، بعضیاتون صندلی نخواهید داشت. صندلی بازی امشب. Please come and take your seats. سم جان علی جان دکتر بش تایمر داره. آره تایمر داره، بهش گفتم اینجا هم نیست. Please come and take a seat. We are waiting for you back there. They will take their pizzas and they sit down. Welcome to another session of Persian Tech Network. We have 3 presentations, short startup presentations, and then we have a very dear guest for our fireside chat tonight. But before that, I would like to remind you why you are here tonight. I know some of you are here for pizza, but that's not what I'm talking about. You are here to make connections. Persian Tech Network. Network is the key word. Those people over there, you want to join us or you want to have a discussion among yourselves? Okay. So you're here to make connections and use the time after the presentations and the fireside chat. Use the time to make the connection by going and talking to a stranger. It doesn't count if you connect with someone you already know of, you've talked to. It does not count. Go and talk to someone who is a complete stranger and ask them what they do and tell them about what you do and try to find some sort of a relation, a connection between what you do and them. This is very, very important. Try to make tonight effective. Not only you're going to learn from our speakers and our presenters, but you are going to go home with some connections that hopefully would be very, very important for your future career. Okay? Enough said about that? All right. So the first part is the 3 presentations. The first one is آقای Mr. Payam Amir Sheibani, co-founder of Archibotics. I hope I have not totally destroyed the name. Can you say that, Payam John, can you say the name of the company again?
Sure, thank you. Archibotics Lab.
Archibotic, thank you very much. Payam John, you got 7 minutes.
Okay.
Go ahead.
Fantastic. Thank you so much for the warm welcome. Hi, everybody. I wish I could be there in person with you, but it's anyways great to connect. My name is Payam. I'm CEO and co-founder of Archibotics Lab. We are a Toronto-based startup focused on architecture, engineering, and construction sector. So what is the problem that we are focused on? So if you think about a day in the life of an architect, or in general, work of an architect, if you do not know someone close to you who is an architect, probably you think majority of their time is spent on creative work, sketches, design, and so on. In reality, during the design development phase, which is the most creative part of their work, they spend up to 30% of their time doing non-creative repetitive tasks. Our mission is to automate as much as possible of those activities and give them back time in order to focus on the creative part. Now, what are some of the examples of those repetitive tasks? We get to that, but let's take a look at the market size first. So if we take a step back and look at the North American market, US and Canada combined. Starting from the left, we are looking at the gross billing of architecture firms across these 2 countries. And as we move to the right, we focus on the share of the residential because those are the projects, type of projects that we are focused on. And then looking at the design development phase, and then that 30% that I just talked about earlier, we are talking about almost $2.5 billion in billing that can potentially be automated and save a lot of margin for architecture firms, and also, again, have a big impact on an industry that has razor thin margins. And if you talk about expansion opportunities, so we are starting from the residential, but we can immediately apply the same capability across different sectors within the industry, such as commercial, health, or education. Now, with this understanding of the market size, let's talk about, the tangible artifacts or activities that we want to automate. So if we talk about creative work, on the left side, you can see some examples such as, form finding or envelope design. So these are activities like for designing the facades of the building. These are the major, creative problems that architects needs to solve. At the same time, beside doing all of that design, they need to produce material and documentation that are required for the investors, required for the owners of the project to report the status of the project, material that are required for getting approval from the cities inside which they're building. So architects need to spend tremendous amount of time producing those documentation on top of their core work in order to get by. And that's where we are focusing on. So where are we with this journey? So we already have a product in the market called Blackline. So we started the low-hanging fruits. Marketing sheets and schedules are documents that are legally required in Canada and also by practice required in America if you want to buy a condo in pre-construction. So we automatically produce those materials. We're going to see an example later on how that looks like. We're coming out with a new product called ArchiAssist that automates project statistics, so reports required for the developer or the owner to know what is the status of the project. And after that, we are aiming to go after creation of the different sets that are required for getting approval. From business standpoint, why is it important? Keep in mind that majority of architecture firms work on fixed price contracts. So the more they have to spend time on these documentations, and that time increases in back and forth over design, it would be at the cost of their margin, again, because they are working on fixed price contracts. And also in terms of team satisfaction, architects have started this career not to produce documentation, but to do design. So it also at the high cost for team morale. Now, let's take a look at the example of Blackline. So what you see on the left, architects typically model the buildings or their design in Autodesk softwares, primarily in North America. So that screenshot from left side is from a tool called Revit, which is an Autodesk software. So our product sits on top of Autodesk product suite. We extract the information and we produce the documentation that you see in the middle. For example, if you want to purchase a condo in pre-construction, you're typically presented with this material that architects need to produce manually. And there are a lot of components and details there. And our tool is able to produce that documentation automatically. Some statistics from a recent project that we produced this documentation for. They estimated to spend about north of 270 hours producing this material manually for a big project that was composed of 115 suite types. So 115 suites for which they had to produce this documentation. Using our tool, they managed to produce all of that entire set under 8 hours, so within a day. So you can imagine how much time it has saved the architect, the firm, and the developer, because there is going to be also a lot of back and forth when they are reviewing these documents. And by the estimation that we did together with our customer, we estimated that they have gained about $15,000 in net margin. And that's a huge number because, again, these contracts usually have very thin margin. So this is just to give you an idea of the type of automation that we provide. A quick snapshot of our team. So I myself bring in more than 10 years of management and technology consulting, working in different industries. Our CTO, Elias, he also provides the same amount of experience working at a staff level as an engineer, both for Fortune 500 companies and startups. And we also have an architect in-house who brings in the industry expertise required in order to build those workflows, understand this industry. This is a very, very traditional industry, so it's not easy to come in and build technology. So we absolutely need in-house expertise to understand what we are building and who we are building for. And that is our pitch. Thank you so much.
We have a little bit of a time, maybe one question. Anybody has a question? No? Okay, we go to this. Thank you very much, Payam John.
Thank you.
Thanks a lot for your presentation. Oh, a question for us? Of course it is possible. You want to come and help me? No, that's okay. I'll move it. Is it good? Okay. Our next presentation is online and is Dr. Mahtab Mir Momeni, and the name of the company is Watch. Can you switch to Mahtab? Can you hear us, Mahtab?
Yes. Hi, everyone.
And Mahtab John, you got 7 minutes.
Thank you. Good evening, everyone. It's a great pleasure to be presenting to you tonight. My name is Dr. Mahtab Mir Momeni, and I'm the founder and CEO of Watch. At Watch, we believe that you should be exercising smarter and recovering faster. The problem that we focus on is that patients that have undergone surgery or are recovering from an injury are not compliant to their exercises that are prescribed to them by their healthcare practitioners, such as physiotherapists. And this is costing them tens of thousands of dollars each year, the patient alone, because it will, they might need to go back to see their healthcare practitioner, have unnecessary procedures, and it's also costing the healthcare system in US alone $50 to $100 billion per year. One of the reasons why the patients are not doing their exercises is because when they're no longer with their physical therapist, they don't know if they're doing the exercise correctly, they're not sure what to do, and this creates anxiety over doing the exercise alone, and they abandon doing the exercise. So our solution to this problem at Watch is that we learn what the correct form of the exercise for that patient is in the initial visit to the physio. And when the patient is no longer in the practice, when they go home, they get instant feedback on their app whether they did according to what the physio prescribed to them and whether they did it with the correct technique. And we also send this data back to the physio or other healthcare practitioners so that they're able to track that the patient's on top of their exercises and are adhering to their exercises. So our technology is an AI-enabled wearable sensor that the patient wears when they go to the physio, and the physio, when they might be doing various different exercises, for example, upper limb, lower limb, core exercises, and the physio tells them this is the correct form for you. It selects what the correct exercise was for them. And when they're no longer there in the practice with the physio, they get feedback on each repetition of the exercise that they do. How close were they to the correct form? And it gives them assurance that they're doing the exercises correctly, for example, to continue and do the exercises. Our business model is a B2B2C and a B2C. So what that means is we sell directly to the patient, $180 our strap band and sensor, and a monthly subscription fee of $30 per month to our app. But we also have a B2B2C, which we go through the physio to onsell to the patient. And we give the physio a wholesale price for $99. So the physio is incentivized to actually offer this to the patient when the patient wants to go home, because they will be making money $81 per unit of Watch when they sell to the patient. our market size based on our business model is for Australia alone, which we are currently based in, is $3.8 million based on the number of physios and based on the innovative physios, the initial innovators that we think we can capture in the first year we're in the market, and based on B2B2C sales. And our beachhead market is private physios in Australia, but we are looking in expanding to US, and our total market for US alone would be $20 billion. Our competitors, none of our competitors do what we can do, which is learn what the correct form of the exercise is from the physio and then give that feedback to the patient when they're not there. So one of the questions that we normally get asked is that how does this compare to your typical Apple or Garmin watches, for example? They can't do that. They won't be able to tell you if you're doing your exercise with the correct technique and learn the correct technique in your visit, to your healthcare practitioner. So where we are at the moment is we're in post-MVP iterations. The initial idea of this has came out of my PhD and my co-founder's PhD. And we are now we've developed our product. We are in post-MVP iterations with a market leader. They call Elite Academy in Australia. And they've been giving us very positive feedback and helping us go to the market. And we are now in the progress of paid pilots with other entities in Australia and overseas. Our timeline is at this stage we are running paid pilots. As I mentioned, we are raising funds, and we plan to launch our product in the market early next year, and we plan to reach 3.8 million annual recurring revenue by the end of 2026. So our ask is we are at the moment raising 800K pre-seed, and that will help us reach our milestones of reaching 3.8 annual recurring revenue by the end of next year. So by us, as I mentioned, my name is Dr. Mahtab Mir Momeni. I'm the founder and CEO of Exawatch. I am an award-winning AI in health care innovator. I've been in the industry for 20 years, working in various digital health and AI industries, such as IBM Research, for example. My co-founder and CTO also has a PhD in AI, more than 10 years of experience in the field, and is a former athlete. And we are, between the two of us, we are very invested in this problem. And we work with a stellar team of engineers, medical advisors, and commercialization people that are helping us bring this vision to life. So we are Exawatch. We want you to exercise smarter and recover faster. I'm sorry I'm not there with you to enjoy the pizza and network, but please reach out to me on LinkedIn, and I would love to continue the discussion.
Thank you very much, Mahtab. Any question? Just one question. Yes, over there. Please mention your name and your affiliation before you ask your question.
My name is Daniel. I have a question about the type of sensors that you're using. Are you able to explain what kind of sensors you're using in your wristbands?
Yeah, they are IMU sensors. So they're IMU sensors, and they are our core differentiation is in the AI algorithms that actually track the exercises. We can actually work with off-the-shelf IMU sensors, and that's what we're doing as well. And we can work, as long as we can get correct data from your existing devices as well, such as Apple, Garmin, existing bands, Samsung bands, we can work with any of those.
Well, thank you very much. Thank you very much, Mahtab.
Thank you.
We have a slight change of a program. We are going to hear the next presentation maybe sometime in the future. So is this mic working, Chris? Looks like a one-man show theater over here. Um, Let me say a few words before I ask our honorable guest to come here tonight. He is a man who sees the world differently, and that's literally. He looks at it differently. Uh, Sam Kavusi has been coming from the area of, he has spent many years working on computer chips, camera chips, sensors, and then he has moved to reinvent how you can look through the eye and diagnose disease in the future. Uh, he is also scientifically bilingual, that he is fluent. In fact, he is a master of computer hardware as well as bioscience, which allows him to discuss things with himself in two different disciplines, maybe argue with himself. At the at Google, he leads a group of retina, which is the retina group, retina science, as well as the AI, which you are combining together. And that would allow, hopefully soon, your smartphone to be able to tell you when you have a disease before your doctor tells you that. I'm very excited to discuss that with our guest tonight. Please help me give a warm welcome to Sam Kavusi. Let's make sure that works, Sam.
Hello.
Grace? Does it work?
Maybe now. Hello.
Maybe now. Okay, that works.
And whoever photoshopped my photo, thank you very much. That's not very realistic.
You can buy that photo for a
Yeah.
very small amount over there. Sam, thank you very much for accepting our invitation to come over here. It's a very exciting area that you're working on, and I have a lot of questions and a lot of areas we have to go on, very little time to go there. But before that, I would like to start with your origin story. You were born in Iran, and you went to school where?
Undergrad, Sharif University. Dr. Tabash was my Riyazi Yek teacher. I guess I still remember this very vividly. Did my undergrad in electronics engineering at Sharif University, and before that did my high school at Firuz Bahram, which is Zoroastrian High School, Razi on middle school, and Razi primary school.
And what made you go into electrical engineering?
I think my father made a mistake or made a good choice when I was in primary school. I really wanted to play chess, and my sister, who was 6 years older, really didn't want to play with me. Then he heard there's these video games now, consoles that you can play chess with. And we went to buy an Atari game. Somebody talked him into buying me a Sinclair Spectrum computer.
And how old are you at this juncture, 16?
No, I was in third grade, so I guess 10 years old.
10.
So 11 years old, I started writing assembly language because I wanted to really put my name in the computer. That was really my grandiose
This is with
first
Atari?
project. No, this was with Spectrum computer.
Spectrum,
so
okay.
Z80 based computer. So that made me think that, okay, this is actually much cooler than what my parents do, which they're both medical doctors. And I felt like I want to build better computer chips that they make better video game consoles or better computers over time. That was the entire...
So your dad, who's a medical doctor, asks you, chose for you to become an electrical engineer. Is that what it is?
He didn't. I guess accidentally impacted that. But I guess he impacted in two ways. One was being very open-minded, and he gave me a feedback that do whatever you want, but only
as long as it's electrical engineering.
No. If you want to go to medicine, make sure that you really love helping people. And I had the privilege or bad luck of observing my parents and their co-workers working in hospital and their clinics.
Both
And
your
I know-
parents are medical doctors,
Yes.
and also other members of the family are doctors. too.
I'm the only useless doctor in the family.
But you further you circled back into medicine somewhat. We'll get to that. yeah.
That's a chip on my shoulder, I
Yeah.
guess. But what I noticed was, they didn't have the freedom to go to restroom whenever they felt like it. So sometimes they had to stay. And to me, liking to play computer games, number one, and being able to go to bathroom whenever I needed to were the two major decision factors.
You should take that as a choice. So you went to Sharif, you got your master's over there in electrical engineering, and then you transferred to Stanford.
Correct. Actually, bachelor's. I came to Stanford for master's and PhD.
Well, okay, I stand corrected. So at Stanford, what happened? First of all, we forgot to ask you, what was your ranking in concours?
Not that good. 39.
Not that good, 39.
My
yes,
sister was
right.
My sister was 4, so I was only 10 times higher than my sister. So
Don't
definitely.
compare yourself with others. Yeah.
But at Stanford, I did my PhD with somebody who just graduated, who actually just retired from the university at Abbas Gamal on image sensors. So those are the chips that they go to digital cameras. And the time that we started, the idea of having a camera on every phone was the crazy idea that some people had. It was very, very early days in 2000.
And then after that, where did you work on camera chips and image technology?
Yes, I worked on camera chips. I worked on IMU sensors. And I watched the process of commoditization of imaging sensors. So I guess there was a factor of back in the around 2000, the cheapest image sensor chip you could buy was about $20. In 2010, it became about $1, and much larger sensors also became available. And always the performance increased as things were moving on. I was thinking about the business side of this. The only part about image sensors at the time, I guess now everybody probably knows about TSMC. I don't think around 2010, TSMC was a very popular company. Semiconductor was commoditized. People are comparing it to cement factories. And I kind of also wanted to kind of get away from building chips and go to the dark side of building systems, mainly following money.
Okay, and so that was in Bush when you did that?
Yes, at Bosch I started to, and I guess I had the idea of also doing something in biomedical. So after I launched the first product I worked on was in iPhone and I guess Nexus and Samsung Galaxy phones. So pretty much everybody had one of my chips in their pocket. It felt good for a few days.
A few days.
But after a few days, I kind of felt the impact is very limited. And next year, I'm going to be fighting again with the other competitors to make the next one. Can I build something that has a little more impact? And some of my friends were working on DNA sequencing chips. I thought that's kind of interesting. Proteomics would be probably more interesting. So spend about 5-6 years at Bosch building, and maybe for people may not know Bosch about spark plugs and dishwashers. They are also the largest MEMS sensor manufacturer on the planet, and it's a fairly large company. And at the time, they had a group similar to Google X projects. So I started one of the projects there, which was all on bioASIC. So making an FPGA-like device, but electrochemical. So we were modulating pH underneath different proteins and correcting for imperfection in vitro diagnostic assays.
So you moved into some sort of a medical-related applications, which was detecting data that comes through a matrix of sensors, essentially.
Correct.
Was this your dad calling you and saying that why don't you do something in medicine, or was it on your own? Was it really?
No, it was on my own, but I think there was a influence of thinking that I started thinking about what would be more meaningful in life, and can I do something that has a much larger impact on people in the best case scenario.
So you're looking for that impact, and after Bosch, where did you go?
So after Bosch, the technology got licensed by I still cannot, this is amazing, after all of these years, I cannot still disclose the name of the company. Very large biotech company licensed it, but I won't say it was a very successful business. End of the day, the return on investment was not that great. So I thought maybe I go back to my roots, go back to imaging, and went to Google Consumer Hardware. I was one of the leads of the first Pixel phone of Google. I know it's not the most popular phone, but
Well,
pretty proud of it.
they were competing with a very, very popular and successful product. That was the difficulty. Now, this idea of retina image being used for detection of whatever, and there are tons of things you can do with it. Where did that start, and how did you end up leading that product
So
or project?
yeah, so I can give the very honest answer, and I can also give a more diplomatic answer. I start with the diplomatic answer. The diplomatic answer is that if you look at different organs in the body, there is one organ that you can see with pretty much with naked eye. You can see the blood vessels, you can see the neurons, and that's back of the eye, the retina. So why is that important is because when you talk to doctors, when they cut somebody open, when they look at the blood vessels and the quality of the blood vessels, they can pretty much say a lot of things about the person. If the blood vessels are rigid because of diabetes, hypertension, other factors, they can say about, oh, this is a person that is going to live long, or this is a person that has a lot of risks. And the idea was, well, if I look at the retina that way, maybe I can actually predict some of those things that doctors can. The other part is a lot of the blindness is something that people want to prevent. A lot of people are willing to lose half of their life not to lose their vision. So if we could help with finding the sources of blindness early on and refer people to treatments that some of them are very time critical. Intervention is time critical. Sorry. That would be also very good.
So
the last part is that retina is connected to brain, and it's actually the largest metabolically active part of the brain. So by looking at the retina and also the eye movement, the idea was, can we look at a lot more information about the brain side of the patient at the same time?
So let's ground ourselves. The two leading causes of trouble for human beings, especially when they get older, is hypertension and diabetics. And both of them cause changes to the vessels, to the veins, to the...
That's correct.
And you can see them. No, there's no other place in the body unless you open up and you go in. You cannot see these blood vessels. You could do some experiments. But if you could do this detection, hopefully your smartphone can do this in the future. And you can do this every day. You can check your blood pressure and, with a very, very... Is that the idea what it is?
That was the desire. But there is a little bit of a technical challenge. So if I guess in the old days, if you wanted to do their eye exam, they needed to dilate your eye because back of your eye is protected very well. Yeah. So you need to look through a little hole, like as if it's a keyhole you need to go through. Yeah. You also need to shine light through that little keyhole. So that's a little hard to fit everything in there. So I won't say it's impossible, but it's very challenging to have this in a convenient form factor to do that. We managed to shrink the size. We built a device to shrink the size and also improve the comfort factor by more than a factor of 10x. But still is another factor of 10x needed to be able to fit in a cell phone.
That's professional, work for you.
Yeah, or giving up. But actually, I want to answer the not very politically correct way.
Yes.
So back around 2016, this was before I got engaged with the project. Deep learning was kind of new, even at Google at the time. It was kind of new, and the idea was, people were worried about, are there good applications, what are the bad applications, other applications that can only do good. And well, medical imaging sounded reasonably good. And then somebody was in charge, one of my good friends, but maybe I don't mention her name. Her job was to find, can I license a lot of medical images that they are pretty much in a standardized form, easy to capture and
label.
available. Yes, and then label them. So it was really started by some crazy guy from Berkeley for many years, started to do a lot of retina screening. A lot of retina screening happens every day in this country. The only problem is most of the times because of nobody got the consent to actually share the images. So this person around 2005, 2006 decided to actually get consent from the patients and actually have those. So most of the reason was availability of data and availability
Which you could use for training actually,
Correct.
and put AI on this one. And if you have tons of images, you can pretty much
Yes.
come
So
up
the
with
fact
this.
was we chose Retina because it was the easiest thing to license
Yes.
the data. But then we come up with ideas, what can we be good for.
So-
but over time, I got convinced and I drank the Kool-Aid that it's actually a good idea.
So that set of data is very valuable, especially if they're labeled. What kind of a labels do they have? Only labeled for a few things, or deep down?
So great question. So unfortunately, that data set had very crude labels only for diabetic retinopathy, so the diabetic eye disease, which is the most common disease that happens. And the patient population was also biased. They were only the people with diabetes that they were getting paid for doing this. Number one. Number two, the labels that you could get for people do for, I don't want to not to judge any doctors, but there may be errors in labeling of images for when it's diagnostic concerns. And sometimes there are many factors like that play. So we ended up actually having all the way to 7 ophthalmologists review each images and relabel those. That was a very expensive project to make sure that we have correct labels. And
What else are you hoping you would capture or you would detect by looking at all these retina?
yeah, so actually the cases that you mentioned, so there are lots of cases that you have, let's say blood pressure is something that is not really measured very well because we all know like there is white coat effect, depends on a lot of people lie in the time. There's a lot of errors there.
People get nervous themselves when they hook up this
Correct.
stuff in it. Yes.
Me included, or at least I blame that sometimes. But the nice thing is the hypothesis is if I look at the blood vessel structure and I can train a model to give the average blood pressure over, let's say, a period of 3 months or 1 year. Very similar to HbA1c tests. There used to be blood glucose tests that, it's one time and depends on what you eat, but HbA1c is the average blood glucose for about 3 months. So that's very valuable, it's accurate. Because then if it's high, it's really actionable. You really need to do something about this. So cardiovascular is definitely one of those conditions. The other one is a lot of neurological diseases. So detecting early stage of onset of dementia, Alzheimer's, and Parkinson. Those are the other ones that.
Could you tell those by one image of the retina? You have to have a series of them and look at them over time.
So having a baseline is important. Actually, we don't have, the only product that we right now have in the market is just detection of diabetic retinopathy, AMD, and glaucoma, diseases of the eye. Those are the classified ones. There are outside the US, there are a few companies that they built devices for risk of cardiovascular disease and risk of neurological disease. They are not FDA approved, like they don't pass the bar of the United States FDA yet. But the goal is to get to those stage.
So what other disease can we, the two of them you mentioned, I'm trying to get to the limit and see how much technological challenges you will have, because we're going to be demanding, once you do these two, we want a lot more. What other things you think you can detect?
Well, we did fun things in the process. So one thing that we did was maybe different traits of people. So if you look at, one thing that I guess we were able to surprise doctors was if you show a retina image to a doctor and say what's the sex of the person, they cannot say male or female, they cannot. An ML model can accurately say that by 99.9% accuracy.
Can do
correct.
it.
So that was why we published that? Because again, our data sets had the sex label attached to them, so it was easy to train.
Yeah.
But there are some small indications that even some like autism, for example, there are to detect somebody levels of autism for someone right now is very subjective, and there seems to be good correlation between the structure of the eye and also motion of the eye with autism.
So it's all, not only the retina, but the movement as well.
Movement of the eye, yes. And I guess we all know each other. When we look at each other's eye, we make a lot of decisions sometimes based on, like, the person is feeling good, bad,
Yes.
this person looks different.
Well, the classic thing is the dilation of the eye, which signals the other person that they like it.
Yes, oh wow.
And the traditional carpet sellers in the Middle East, they carried colored glasses, so their opponents, their rivals would not see that they like the price or the carpet and all that. So I can imagine something like that could be done with an iPhone in the future to dig into the emotion. There's one other thing I came across from Oculometrics is a company in Berkeley. Do you know about them?
Yes.
You know what they do? Let me remind you. Okay. This was a very surprise to me that I don't know how many baseball fans are around here. There are a few over here. But the only fact you need to know is recently two very high hitters in baseball, they were offered contracts of about $700+ million over 10 years. So there is money there. There's value there. So this company, Oculometrics, is putting all the baseball players in a retina scanner, and they bet that they can tell the owners which one of these guys can hit better. If they can do that and find, how quick your brain connection with your muscles work, then the sky is the limit. We could be able to say a lot of things.
Actually, so NASA has been doing a lot of oculomics-based tests for the astronauts for many, many years. The issue is, if you look at the way NASA does it, it's like in a big room and the setup is prohibitive. And one issue is light definitely shrinks your pupil. So if you want to see if the carpet arouses you and opens up your pupil a little bit, I need to make sure I don't shine random light to your eye or my information get destroyed. So that was actually the intent. That if you look at our device, we have a light shield still in a fairly small form factor, but to make sure that it's practical. And those are all little small details with the cell phone that, I don't want to send you to a dark room.
Well, eventually everything has to be on a cell phone so we can do it.
And
the application I'm thinking that would be useful for people over here would be if when they go dating, they can test the other person's whatever, In fact, you can make a good lie detector on this one.
That is correct, except you need to make sure CBD also dilates the eye, so just...
Well, it's not the only dilation. I'm thinking about if you have a bunch of data, a bunch of images, and you can label them, or you can put people through tests that say, I'm lying, I'm not lying, I'm lying, and then see the differences in the retina.
No, this is actually this has been the intent of having a full stack of hardware, software layer, and also deployment in medical space was to get a lot more data with a lot more associated label and metadata. I have to admit it's harder to do than in principle.
The actual collection of data.
Collection of data, a big part of it is due to HIPAA compliance and privacy rules. In the United States, it's sometimes very challenging to collect all the data.
So let me ask you this: when you mention HIPAA, if HIPAA was no object and you had a infinite amount of money, what product would you go after? What would you make? No limitation of FDA.
Well, to me, I want to be ethical to begin with, and I think I do want to commend, even though FDA has caused occasionally pain and suffering and a lot of headache for us. But overall, I think the intent is very good, and I think the product has to pass in my mind, it's important that you don't do harm. And there are remote cases I can imagine making harm.
Well, we're not thinking of making harm. We're not, going into military thinking and all that. But suppose you were not shackled with those limitations. And, we're not going to send it to the market and hurt people. What would be an interesting product that you can conceive of? And
yeah. No, so the cases that like my heart goes a lot to is if you go to medical practices, a lot of issues, they happen because of undetected cases that they are rare. For example, a lot of inflammatory type of diseases. So one thing that you can detect from the retina is inflammation. There is a specialty in ophthalmologists, hopefully you never heard of it, it's called uveitis, because if you end up seeing a uveitis, you have to take it very seriously. It means infection in the back of the eye, and if you are not seeing a good one, you're in, it's a very high risk situation to be in. But there are asymptomatic levels of a uveitis, and those are when your body and your immune system is not in the right state or not in the ideal state. Being able to find the people, so let's say if my ideal case would be in any clinic or any hospital, everybody would get screened, and the high-risk patients that they would probably get observed to have an inflammatory situation, maybe after 5 hours, they get diagnosed at the time of the check-in. And that would help with the way that the workflow would adapt to actually see those persons. Most of the time, just a steroid injection can solve a lot of problems and prevent death, prevents major costly procedures. Why do I like this? Is because to me the impact is very, very high, and again, comparing with my parents, that I try to compare how many patients did my dad see during his lifetime, maybe 40,000 patients. And can I claim that after all of these years, I say 40,000 people, 40,000 people that we prevented their blindness? I can't claim that yet, because only 2% of the people that we refer end up actually being really at high risk, if I make sense.
Well, but surely it does. Surely your goal is to make this so available that is, first of all, it's a lot easier to use. It doesn't require a very high-level professional to operate it, and it's accessible throughout the throughout the land. So in even small villages, if you can do it, at least the rudimentary checking through an iPhone or in your case Android, you have succeeded, and that number will go beyond 40,000, right? Is that what your goal is?
That was the goal, but we are nowhere there yet. So
well, of course. That's why you're still working.
With our service, now we are offering service in actually rural towns in Texas, Louisiana, in actually parts of the country that I never been to, except for now we have customers there. The impact is actually really nice, and actually being able to offer this to people, it actually definitely warms your heart. But the issue is, even though, because it's a medical device, actually going back to your FDA, when things are a regulated medical device, it's not just actually passing the FDA bar. The person who has to operate has to have certain levels of licensing. Yeah. The next step, and the next step, and the next step.
But that's easier to achieve than being a full doctor, yeah?
It is much easier, but they add a burden. So like putting a device, so our device can totally work in any retail space, in theory. But in practice, the licensing and all of those, they put a lot of prohibition there. So that's where, if the FDA didn't exist, or if this was not a regulated device, you could definitely put stuff in retail.
Like a blood pressure machine, which is in every Walgreens that you can see.
But nobody, sorry, can I interrupt?
Sure,
and say,
of course.
Nobody uses those. At least I never seen people use the blood pressure machines in Walgreens, and maybe the reason is because, oh, sorry, not that many people use it. And the main reason is, first of all, that's like you can also buy one. It's not that expensive.
Yeah.
Number two is,
what is there while I'm waiting?
It's not very actionable. Because it make you upset, and the idea is from the eye, you can only give more, way more
A
actionable
lot more,
results.
yes. The knowledge that you get, the language model that, the model that is actually you're developing, is it, you think, based on the data that you have over here, extendable to the rest of the world? In other words, once you train something and make it work, can you take that to Iran or to China and have the same results? Or there is something about, I don't know.
No, so there is definitely ethnicity variation on retina and also front of the eye. But actually, the nice thing about the United States is actually good diversity of the population.
That's right.
So we tested in United States, in India, in Thailand.
Similar results.
Similar results, yes.
What is your goal in 5 years? What would be great success for Sam in 5 years?
So
2030.
So there is about 7 million people in the United States that they are missing their annual diabetic eye exam.
7 million.
7 million. About 14 million have to do it. About half of them do it annually, and half of them miss the annual eye exam. We launched our device about 2.5 years ago, and we made a tiny bit of a dent. If we can go to 3 million, reduce that gap by 3 million,
You would be a proud son of your mom and dad.
I mean, I'll be very proud.
Excellent.
I used to have a much higher bar, I have to admit, but once you actually see the actual process of selling, deploying, and convincing everybody to do this, and everybody has to make money, things have to work out for everyone, you kind of become more realistic, I guess.
But Sam,
I have to admit, B2B businesses are much easier.
We are very proud of you and of your achievements, and we salute your achievements. Thank you.
Thank you so much.
We have time for a few questions. If you raise your hand, we can pass a microphone. Do you have an extra one? Yes. Questions? You have one over there. Dr. Murthy has one. Yes. Please state your name and your affiliation. Other people, if you raise your hands. Okay.
I'm Dr. K.R.S. Murthy. Thank you. Normally, when people get to some age, their eyesight becomes such a way that you need a glass, right? Special glass. Is it true for everyone, human beings? Are there special cases where they don't need? Is there, in the same family or same group of people, same ethnicity or whatever, and what requires that not to happen?
He is a retina scientist, not an eye doctor. But
yeah, I'm not an eye doctor, but I hang out with enough doctors.
I
hang out with enough doctors.
I know other colleagues of you, Dr. Ming Wang, and many other people who worked in this area.
No, so the issue with presbyopia is that your eye lens, the crystal lens of the eye, starts to get rigid, and it's been a holy grail for probably industry. If somebody comes up with a medication to prevent that, everybody would love this. One way to actually compare that, if you look at the nails of the people with age, they also get thicker and they also get more rigid versus a younger person. So they happen pretty much together. As far as I know, there is no way out of this. There is a second part, which is cataract, which is cloudiness of the lens. That also happens, but there is actually solutions, and you can also remove and change the cataract.
These all will be solved if they find the anti-aging elements of the body. Okay, the gentleman over there, I guess Mehdi.
Hi, Sam. Nice to meet you. Jonathan Govette, the CEO of Oatmeal Health. We're a care coordination AI cancer screening startup in California and a few other states. What is one of your main challenges right now building your services or distributing them today that maybe we can help you with? We have about 250,000 patients we work with currently.
A little plug over there. Okay, thank you.
Hey, got to make it fit it in, right?
No, actually, yeah. So I would say one of the largest challenges for us has been the feedback loops of the finances. So people make money immediately using our service. They get some ROI in 3 months, but they actually get the major amount of money back in about 18 months. That 18 months, I mean, a lot of primary care doctors, they don't even want to stay in the same practice for 18 months, so they don't care as much. So that causes a lot of latency in adoption and utilization and all of those. And maybe that's the challenge of screening in general.
It is, and I think that's where we can maybe offer some assistance.
Love to chat.
Afterwards. Definitely. Thank you.
Any other questions? Therefore, on behalf of Plug and Play, Persian Tech Network, Iranian entrepreneurs, and the Iranian community, I thank you, and the Amidi Group, I forgot. And the Amidi Group, I thank you for spending the time with us and answering our questions.
Thank you very much. I'm looking forward to networking.
Thank you. Thanks a lot. And this is networking time. Sam is available for your questions, and then among yourselves. Please use the time to network. Thanks.